Hi, good morning, everyone. Welcome to NextGen IT courses. So today we are starting AWS combo batch that will have AWS Solution Architect plus AWS Networking and AWS Security Specialist. So who are new here in the NextGen? Let me introduce ourselves. We are providing online training worldwide related to network security, cloud security, and cyber security. Basically, trainers are working professionals. They are having industry experience, and after their working hours, they are taking classes in the evening, weekdays, and weekend in the morning. So it will be live classes plus recordings as well, and 100% practical session we are going to deliver here. So we are having our trainer as well, uh, Mr. Uday Singh. Hi, good morning, Uday sir.
Hi Sachin, how are you?
I am good, sir. What about you, sir?
I'm good too.
So, Uday sir, we can just do one thing. You can introduce yourself, what expertise
Mhm,
you have, and we can give some guidance as well why they should choose AWS Cloud and what opportunities they can have, and we
mhm,
can discuss a little bit about the syllabus, and we can
mhm,
have some inquiries from the students, and then we can start with the fundamental of cloud today, and you
mhm.
can even ask their expectation as well by attending this batch, what they can expect after that, right?
Yeah, sure.
Yeah, over to you, sir. Thank you.
Mhm. So everybody join. Can we start with it?
Yes, yes, sir. You can continue. Yeah.
Just give me a minute. I need to check my headset. Okay, so hey guys, I'm Uday, and I'll be your instructor for this course. And let me quickly introduce myself before we get started. So I have almost 12 years of experience in software engineering, and a big part of that was being spent on the backend engineering system, working directly with the servers and how they are managed. Right now, I'm working with Alphabet Technology as a team lead in the software engineering. And throughout my career, I have mostly worked in the fintech space. I have built a core banking system used by banks, a loan management system, and a mutual fund application. Along the way, these platforms have had to handle a huge number of requests. So I have spent a lot of handling servers for high throughput and low latency. And we make sure the things stay fast and stay up even under high load. Okay. So everything we are going to cover in this course isn't just a theory for me. It comes from real problems I have had to solve on real production system. Okay. So we can just get started. And I just want to ask everyone that I want to understand my audience. So if you will uh, write in the chat what you do, you are a working professional or you are in the college. So it will be very helpful. So if you can just write in the chat.
Yes, guys. If anyone can speak up about their profile and experience, so we
You
can.
can speak up
Yeah,
too.
understand. Ashok, Devjyoti, Dinesh, Liaquat, Manaswi, Rashmi. Anyone, one or two guys, please.
Mhm. Okay.
Rashmi is software engineer and as a back developer.
Mhm.
Yeah, thank you, Rashmi.
So if you are not comfortable, just drop in the chat box. You can write it, right? It is fine. Okay.
Sanjay is working as a senior network engineer. Yeah, thank you,
Mhm.
Sanjay. So thank you for the participating,
Mhm.
guys. If
Okay.
anyone else also want to introduce, they can do that. Into cyber security, Tapan. Yeah.
Mhm.
Liaquat is a working professional, new in cloud. Yeah.
Mhm. Okay. Okay. Thank you, guys. So let me share my screen first. It is visible, right, Sachin? You can see it.
Yes, sir.
Okay. So, before starting the course, just I want to ask you if you have any things to that I can take in mind. Like you are all beginners, what is the level of your understanding in the cloud platform? So, if you can tell me, it will be great. So, basically, in the lecture, we will cover the cloud computing part, the fundamental of the cloud computing. Then, we'll start with the AWS, where we will learn everything, which will cover the certification of the AWS Cloud Practitioner and AWS Security. Okay, and we will see the secure networking, how we can perform and how we can uh, secure our system. And at the end of the course, we'll also try to deploy one of the services on EC2 instance, and we'll host a serverless website on the S3 as well. Okay. Hey, hi Dinesh. Okay, so you are asking what should we expect from this course? As we'll be covering every part, most of the part which is required in the cloud development from the scratch to the advanced level. For the cloud platform, we'll be using the AWS. Okay, and we'll be knowing the all the available uh, parts they have, the services they provide. Okay, right, like EC2, S3, Amazon, Aura, we have RDS, Transform, DynamoDB, everything which you will need to learn as a software engineer as well as a DevOps engineer. Okay, we'll be covering the Linux as well here, shell scripting Linux. The commands will be executing on the operating system. Okay. Anything else? Anyone want to ask? Okay, fine. So let me quickly start with the fundamentals. Uh, like what is cloud computing, why we use it, why we really need it, what is the need of this computing, what we are doing before, like these companies like AWS and the other cloud platform which are giving the services was not previously there, right? In the 2000s, suppose you are in the 2005, okay? So this was not there. So what we are doing before that, okay? So before we learn AWS, we first need to understand one important things. Why was cloud computing invented? This is the most important question you should ask first. The need of the platform. Okay. So if you understand this question, everything else in the AWS become much easier. So this is the very important question. Why do they invented the cloud computing? So in our day-to-day life, how many of you uses a WhatsApp, Instagram, YouTube, Netflix, Amazon, ChatGPT? So everyone uses it, right, in their mobile phone or laptops. Okay. So let me ask you one question: that where are these applications are actually running? Are they running inside your mobile phone? These applications like Instagram, Netflix? No, right? These are running on somewhere else, servers, correct, Dinesh? So, server is a very big word to understand. Like this is seems like a technical word, server, but it is not like that. Okay. So many of you will think a server is a magical machine. It isn't, right? A server is simply a computer. The biggest difference is its purpose, how it works. So suppose you have a one laptop. So this is also we can consider it as a server. Okay, but this is for your personal use. Okay, and the server is a PC or a group of, it can be a group of PCs, right? Or the CPU, I would say, because in the servers we don't really need a GUI, monitor screen like which we have in our laptops and PCs. Okay, so for example, suppose your laptop may have a 16 GB of RAM, Intel i5 processor, and 512 of SSD, right? 512 GB of SSDs you can have in your laptop, but a server in the AWS may have hundreds of GB of RAMs. Okay, not just 16, and the many CPU cores, and the server and the several terabyte of SSD storage, and multiple network connection, power backup supplies. So if you are using a laptop when the power cut off from your home, so it get closed, right? But in the servers they have the power backup, so they can power the system even though when the power supply is cut. Okay, and the server's job is to stay 24 hours a day and 7 days a week to stay online. Okay, you can't run your computer for a 24/7. Okay, you can run it, but we'll learn why servers are needed actually. Okay, even though we have the computers and the computer are still a server. Okay, so just think of you are building a shopping website, okay, and someone had built it. One customer, suppose, opened your website, so there is no problem. You can run it your website on your PC and the laptop as well. But 10 customer open it your website, but still there is no issue. You can handle the traffic. Now imagine 1 lakh customer open your website during a festival sale or anything. So will your laptop be able to handle that? No. Okay, because the traffic is huge. It will become slower, it will get crashed. So that is why a company uses server instead of the personal computers, even though they are the same thing. Okay, and you must think of where these servers are kept, where it is stored. Okay, so servers are not kept in someone's office. Thousands of servers are kept inside huge buildings, and we call those building as data centers. So this is a word you must know it, data center, where we store our servers. So a data centers contains thousands of servers, powerful internet connection, and they also have the cooling system, then with the fire protection, security camera, for sure, and the backup generators. So they need to manage the backup as well because your application is running on it, and the UPS system. Okay, UPS system means uninterrupted power supply. So when the electricity went, they have the UPS system, so they can give the power to the servers, and the engineers working 24/7. Okay, so this building cost in crores of rupees to build and maintain. Okay, because they have the infrastructure, then the resources available every time. Engineers are working 24/7. So you must first think of life before cloud computing. So what we were doing that time. So let's imagine it's year 2005. You went to you want to create an online shopping website. So what do you need? First you need to buy servers. Okay, then you need one office space to place those servers, and the air conditioner to cool it down, and the UPS. So when the power gets off, you can continue supply the electricity on to it the server, and the generator, internet connection, network switches, routers, firewalls, database, many things. Okay, and you need to do the backup for you of your own, right? So after buying everything, you install your application. So you just wanted to deliver one online shopping application, but instead of building that, instead of focusing on your business, you are now building your office space. You are building with the server, doing the backup, giving the internet, firewall. You are managing the security, everything. Okay. So now imagine your business suddenly become popular. Okay. Yesterday you had a 50 and 500 of users. Today you have 5 lakh users. So what happens? Your server will become overloaded, right? You don't have that much of capacity in your server. Now you have to buy more servers. Again, you will purchase hardware, wait for the delivery, then the delivery guy will come, then the engineers will come, will install it, configuring the network, then you move your application on it, right? So these takes time. During this time, customer may not be able to use your application. This means your company loses money, right? So the biggest problem was before, there was some problem. Let me define majorly two problems which we have in previous time. So problem number one was uh, high initial cost. What I already told you, right? So before earning even 1 rupees, company had to spend lakhs or crores on infrastructure. This is called capital expenditure, capex. Okay, if you can see it here, on premises, if we are building anything, then we need to take huge cost on the day one. Even we are not earning anything, we just started a software development company, we are building up products for our client, but before that we need to invest lakhs and in crores as per our market size. Okay, but the problem number two was guessing the future. It was worse than this. You can buy a one server, you can start with this. But suppose you expected 10,000 user. So you buy 10 servers, but only 2,000 users come. Okay. So now the 80% of your servers remain unused. Fine. So your money is wasted. And you can think of the opposite of this scenario. You expected 2,000 user, but the suddenly 1 lakh user came. Now your application crashes because you don't have enough servers and the resources. So again, you need to start with the scratch. You need to buy another server and need to configure it. Okay. So the mainly the cloud computing solve this problem. Instead of buying servers, companies now rent servers whenever they need them. This is called cloud computing. Or you can in the general life you can think about the electricity as well. So do you build your own power plant if you want electricity in your home? No, right? You simply use electricity and pay your monthly bills from the government. They give you or the uh, private provider. So cloud computing works exactly the same way. You use computing resources only when you need them, right? You pay only for what you use. No need to buy expensive hardware. So cloud computing is the delivery of computing services, storage, and databases, networking. They have everything on their platform, and they charge you on the basis of what you use. So the AWS, Microsoft Azure, and the Google Cloud are the three biggest companies that build their giants data centers. Okay, where these servers are kept in. So these giant centers are already built by the AWS. Microsoft is also big there. Azure they have, and the cloud, Google. Google Cloud, GCP. Okay. So they have already built the giant data center so that the rest of the world doesn't have to. They can just use it. They have the all the resources. So in this course, we'll be mostly focusing on learning the AWS because it is the widely used cloud platform in the industries. And you, as an engineer or a DevOps engineer, or even a engineer, I would say engineer because everyone here is engineer. Maybe they are networking engineer, cyber security, Java developer, anyone. Okay. So as an engineer, you must know a cloud platform so that you can deploy and you can manage your applications when the traffic is low, and you can increase the server size as per your need when you get the traffic from user of 1000 request or 1 lakh request per second. Okay. So from the cloud computing, I would say you must need to understand, like we are starting it from very basic. So you must understand applications which are on your phone is not running on your phone. It is running on the servers, and the servers lives in data centers, which are extremely expensive to build. So here we named it at a cloud computing. So does it mean it stored in the cloud? In the sky? No. So it gets stored in the data centers. Okay. And before the cloud computings were introduced, the companies had to build their own hardware upfront, which is capex. You must know this word capex, which is capital expenditure. Okay. And guess their future demand. So people before this buy the hardware, then guess the future demand, what will be the amount of a hit they are going to get on their application. So both were risky and wasteful. Okay. And cloud computing let you rent computers, powerful computers on demand, like an electricity bill. Instead of owing it, you are not owing the electricity plant, you are just using it and paying the bills. Okay. So AWS is the one of the companies that owns this infrastructure and rent it out to the world. So over the world, they have their servers and the data centers, which we'll see in the later sessions, that they have the data centers in the Virginia, then India they have in the Mumbai as well, and then Sydney's. So these are the safest location and the uh, regions where they can keep their servers. Okay. So across the worldwide, they have the data centers built in. So we others don't need to do the efforts. They can just pay the price and use the servers. So here the again the concept came in, like what is on premises and cloud. So I want you not to just learn is as a you just want to learn it. Okay. I want you guys to learn this as a you can use in to your day to day life, how we are identifying the problems, what we are doing to solving it. Okay. We are not just learning anything and want to do the test or pass the certification of the AWS that will give us a job. This is the secondary factor. You must know the things from the scratch to the advanced, which you can use when you are really working on the system. So we'll be doing all the practical, we'll be understanding the concept in the deep, why it was get introduced, why it was needed, really it is needed or not. Okay. And can't we do without this? Suppose in the AWS we got several things. They are the services of the AWS, right? Like Amazon EC2. So what they are doing, what is EC2? So these are just computers or the CPUs which are running on the data centers. So you right now you know the data centers, right? The buildings, they have the big buildings built in crores. They have 24/7 engineers working on it. Okay. So in that building there will be one CPU where this service is running, EC2. When you are buying this server, you just buying a virtual machine kind of thing. You are buying a computer so that your application or your anything that you want to deploy that can be run on this server, okay, 24/7, with all headache will be of the AWS. You don't need to manage it by your own, okay. So is this the thing we can't build it ourselves? So this is not like that. So cloud platforms are not doing anything which we can't do. Okay, they have everything which is already there. They are just making your life easier and to focus what you genuinely need. If you want to build your own infra, you can build it. But if you want to own your business, whether you want to, you are a uh, means you are a development platform, you are an engineer, you want to take care of your business, you have build a online shopping application, a food delivery application. So your business is that, your business is not to manage the servers, so that will be care by the AWS. But it is like something that we can't build this of our own, so this is wrong. Okay, so EC2 is just a running computer. In my system also, I can say this is the EC2, my laptop. Okay, so my laptop can be also EC2. Then we have S3. It is a storage system. You can read it: secure, durable, and scalable object storage infra. So can you not build this? You can build this. Even we have a open source tool available, right? Like a mean.io, we have mean.io to store the documents, objects inside it. So just we need to manage it our own. Okay, but these services are giving like think of a Swiggy, right? We can cook our food too at our home, right? But we still order it from online using Swiggy, Zomato. So they are just making our life easier. We can get it done by ourselves as well. Okay, so back to the on premises versus cloud. So now that we know why cloud computing exists, so let's compare it directly with the old way of doing things, what we call on premises or on prem for short. Okay, so on premises simply means the servers are physically present at your company's premises. You brought them, you own them, they sit in your building, and your own teams, your own engineering teams looks them. Okay, so suppose if your father own a shop, would he prefer to buy the shop building or rent it every month? Both have trade off, right? And that exactly the on premises and cloud debate. So in the on premises, who buy the hardwares? You, right? In the cloud, the provider AWS does it in behalf of you. Then we can say in on premises, we need to give the upfront cost, and in the cloud it is almost zero. You don't need to do anything, even though you are getting some free credit. Okay, AWS free tier, get started for free with up to $200. So it'll give you the free credit, you can start, you can host your website. After that they will charge you. Okay. And scaling issue, you previously had a 500 user, but some festival got in, and your website got high traffic. So in the on-premises system, you need to buy the hardwares that can take weeks as well. But in the cloud, this will going to happen in few clicks. Okay, in the minutes. And for scaling down, if you want to scale down, you want to cut off the resources, so hardware sits idly. Okay, you have added your hardwares, now they are not in the use, but you can just in the cloud platform, you can just stop paying for it, you can stop the server, that server which you have introduced for the high traffic, you can do it. And in the on premises, you maintain everything, your own IT team, and in the cloud, like AWS engineers or the uh, GCP, Google engineers, they maintain it for you. And the most important part is disaster recovery. So in the happy scenario, you can do everything. But what if you lose something? You are building, as I said, I have experience in building a core banking system. Suppose applications are running from 20 years. We have the bank data, okay, and now you are storing it on your own premises. Okay, so you build it yourself. So it is not like that we can't do it in the on premises. We can do it. It is the same way like engineers are doing in the AWS data centers. Okay, and the global reach. Suppose you your website got attention from worldwide. Okay, so you need to so make it your website faster. Suppose your website are getting used in the US, so when the US customer is opening your website, the request is coming from US to India, so this will get delay. Okay, the network latency will happen. So you need to build your own on premises center in US, but in the AWS this is nothing like that. You can build the uh, you can change the region, you can select it, you can add a server on the different regions as well. So the sign so this is the biggest shift here is to capex to opex. Okay, so capex, as we understand, this is a capital expenditure, is more spent upfront to buy an asset, and the opex is operational expenditure, is money spent as you go, like a monthly expense. Cloud computing turns a huge upfront investment into a predictable monthly billing. So they charge you as per the monthly billing, as per your uses. Okay. So suppose a startup want to launch an app on premises, they need to spend 50 lakhs on the servers before writing a single line of business code. That earns them money. Okay. On the cloud, they can start with the server that cost a few hundred rupees a day and only spend more once real customers start coming and paying them as per their scale. This is exactly why almost every startup today is using the cloud first. They are using the cloud platform, and the demand of the cloud engineers and the engineers who know the cloud platform is huge, because everyone here is using the cloud platforms. So you will have a tremendous opportunity in your uh, personal life as well after learning this course, because the demand is very high, and the AWS provide us certain certificates as well. If you can get those certificates, which is good to have, but the main thing is the knowledge, how much you know. Okay, the certificate will get you a job, but in the job, when you will try to solve the actual problem, then your life will get much difficult when you don't know how to manage the system. Okay, so everything which we have covered till yet, it seems like cloud is everything. So we can think of, is the on premises is dead, no one using it? So it is not like that. Some organization, bank, government departments, defense hospitals still keep some system on premises because of the strict data regulations, security concerns they have. Existing heavy systems, suppose they are operating from years, from decades, Okay, so suppose Indian Army is using some of the uh, system, so they can't keep their data in the AWS, right? So they can use the services of AWS, like EC2, S3 storage, everything. But for the data storage, they must need to create their own data center kind of stuff. Okay, if they need the security. So this is very important part of the certification exam as well. So AWS never say on premises is wrong. It says cloud offer advantage in cost, speed, and scale. Okay, but the hybrid setup which we have, we can build it, right? Which we'll cover shortly, and exist precisely because full migration isn't allow practical on one day. So for this on-premises versus cloud, you need to understand what we have learned is on-premises you manage and you own the hardware in your own building. Cloud you rent computing resource from a provider like AWS or the GCP. And the main concern of the business is the financial shift from CAPEX buying upfront to the OPEX, pay as you go. Okay. So here the cloud wins on the speed of the scaling and reduce maintenance burden. You can, the speed will be huge, right? You can on the simple clicks, you can add the servers, you can remove it as per your need. But the on-premises still exist for regulatory or the legacy systems. Legacy means those systems which are running from the decades. Then there is a word called IS, PS, and SAS. Okay, so what does this mean? So here, the higher you go, the less you manage, and the more AWS manages for. Okay, this is the one of the most commonly asked question and the topic. So let's slow down here because this is the very important part in the cloud computing. So cloud computing isn't one single product. AWS offers different level of services depending on how much you want to manage yourself versus how much you want the provider to manage for you. The easiest way to explain this, like a pizza analogy, and honestly, it works so well that almost every cloud course in the world uses same version. Okay, so you can make your food at home versus you can order it from Domino's as well, right? So you can cook at home. It is like on premises. You buy the kitchen, the gas stove, the utensils, the raw materials, and the vegetables, and you cook everything yourself. Maximum control and minimum and sorry, maximum efforts. Okay. So the control is the maximum you can do everything, and the effort is also a high because you are managing everything. So option two is infra as a service. Okay, we can choose this as an option two. So think of fully equipped rental kitchen. Okay, someone else build the kitchen, install the gas connection, give you the stove and utensils, build you still, but you still bring your own ingredients and you still cook the meal yourself. Okay. So the someone else built the kitchen. You don't own it in the infrastructure as a service. In the cloud terms, AWS give you the raw computing infrastructure, a virtual machine called EC2, which we have shown here, which we have seen here. Okay, the EC2 and storage and networking. They will give you install your own operating system, update your own software, you own application. AWS jobs stop at here, right? They just given you the platform. Now here is a working computer connected to the internet. Everything on top is your responsibility, like Amazon EC2 instance, which we have. Similar to this, we have a platform as a service. Okay, so think of a restaurant central kitchen setup. Okay, where they even give you a semi-prepared base like a pizza base. So here we have the everything we need to do it our own. They just give you the kitchen. They just give you the platform. Here they have given you the platform with the some more ingredients, like they have given you the pizza base and the sauces already made. You just add your own toppings and put it in the oven, and you don't worry about the dough recipe or the oven temperature settings. They have given you it. That's handled for you. Okay. So in the cloud terms, AWS manage the operating system, the runtime, the several uh, resources. You simply deploy your application code. You don't patch servers. You don't manage the database engines internally. You just focus on your code. Like we have AWS Lambda or Elastic bench stack. We'll learn everything these words in the upcoming sessions. And we have this SaaS, software as a service. Now, for this thing of a just walking into a restaurant and order and finished plate of food. You don't cook, you don't manage the kitchen, you don't even see the kitchen. You just consume the final product. So the entire application is built, hosted, and managed by someone else. You just log in and use it through a browser. So this is a software as a service. For example, we have a Gmail, Netflix, Zoom, this Zoom meeting, how we have connected. So these are the SaaS platform where you are not doing anything, just you are using the services. Okay. So to summarize this, think of LAS as a rented infrastructure. You install and manage the OS operating system and app inside it. And for the PaaS, you bring your own code. The platform handle the OS and runtime. And for the SaaS, fully finished software, you just use it. Okay. And also, as you move uh, from this level to this and this to this, you give up control but gain convenience. Okay, and AWS take on more of the responsibility. Then we have a concept of a public, private, and hybrid cloud. Okay, so we have talked about the level of services which we have. Now let's talk about the ownership models, who the cloud is actually built for. So we have the public cloud. This is what most people mean when they say the cloud, a third party provider like AWS, Azure, or Google Cloud. They own giant data centers and rent out computing resources to everyone. By everyone, I mean individual, startup, governments, huge corporates. They all share the same underlying infrastructure. This is what we'll be using throughout this course, the public cloud. So similar to this public cloud, we have a private cloud as well. You must know of it. The infrastructure is used by one single organization. It might physically sit in the company's own data center or even be hosted by a provider, but it is not shared with someone else. Like a bank, we have bank do this, then we have a defense organization and some government bodies prefer these for extra control over security and performance. Okay. So you can think of it like owning your own independent bungalow. Nobody else lives there. you have the full control, but you have also bear the full cost in the private cloud. Then we have the hybrid cloud. This is the mix of the both. Some systems stay on premises or on a private cloud, usually for sensitive data, and as I told you, for the legacy system or anything which have the strict regulation. While the other system, especially anything that need to scale quickly, like your front end and the back end systems, or reach customer globally, run on the public cloud, which will be managed by the public cloud provider like a GCP or the AWS. So, do you know why would a bank not put the 100% of its system on the public cloud, even though it is cheaper or fast? So the answer is the security and the governance regulation. Okay, they can't put your data on the someone else's data centers. They are secure, but the other government body owns it, right? Then we have regions and available zones. Uh, so now we start getting into how AWS is physically built around the world. And this is genuinely one of the most important topic in the entire module. So we just need to ask a question to ourselves, like if the AWS has a data center, where in the world do we think they are located? Just one city, just America? So no, it is not like that. So AWS has built data centers all across the globe, and they are organized them in a very specific, deliberative structure. Okay, so there is a word called a region. You must know about it. A region is a physical, geographical location in the world where AWS has a cluster of the data center. For example, like in the Mumbai, we have, then in the Singapore, they have, then the Virginia, then Sydney, they have the physical data center. And each region is completely independent. It is not like it is interconnected. Think of a region like a zone or a state, a large geographical area where AWS has dedicated to set up their shop. Okay, so they can do it in one where as well, right? In a part of the world, they can have their data center. Why this is needed? Why they are adding their data centers in the every region, right? So why does AWS have many region instead of just one giant one in America? They can uh, have one in America too. Why they are building across the world? So the first answer is the latency. So in the software engineering, when you are dealing with the high throughput, by high throughput I mean a large number of requests, the latency matters. When you click on anything on a button, even your request goes from client to server. Here you have joined through Zoom Meet, so this is the client. Okay, so even if I click on the leave button, okay, or the anything, my client, which is a Zoom, is sending the request to the server. Server is nothing but a computer where our program is running. Okay, so these calls, how it is going, it is not going through a wire, right? It is going through a network. So in the networks, the network, they have some protocols, like we have a TCP protocols, where the TCP protocols divides the request in the packets, the smaller packets. Then in the packets, even though you have sent one request, but it will get divided into multiple packets for the security reasons and for the convenience, right? And your server gets the security packets in the chunks. Okay, And the delay between a server to client communication is called a latency. This is also a technical word which you must aware of it. So the physical distance data has to travel affects the speed. Suppose a client from US is trying to open your website which is deployed on the Mumbai. So network is in the network it is traveling the request from US to India. So if your user are in India, hosting your app in Mumbai gives a much faster experience than hosting it in the US. Because if user is in India, the request will, even though it is very fast, the request in the network goes very fast in the packets, but it still takes time. When you are working on a use system, you think of every flaws which can affect your latency or the behavior of your application and the user experience. Okay. And also for the compliance and compliance policy, we also have, so many countries have law like citizen or financial data to stay within the country's border. So having a Mumbai region, its Indian companies stay legally compliant. So you have your data. Suppose you are a customer of India, a people of India, but your data stored in the US or anywhere else. So the regulatory bodies and the government is not allow you, right? So this is one of the second reason. But the most important reason is the latency, the speed, how the we can reduce the network traveling. What to say? The network traveling. How we can slow down the space between one client to one server. Okay. Then we have zones. Now, instead, every reason AWS doesn't build just one data center, it builds several and group them into zones. Okay. So, a zone is one or more physical separate data center within a region, each with its own independent power, cooling, and networking, but connected to the other zone. Okay, so inside the region, we have the multiple zones, and those zones are connected with the other zones through very fast and low latency links. Okay, so most regions have a minimum of three zones. This is an actual uh, thing which you must. This is some of the questions which you can get up, like how many of the minimum zone is available in one of the regions. So the answer is three. Okay. And this is strange. And why does this matter? Why we they are dividing it in the zone? Why there are multiple zones? So think of you host your shopping website in just one data center, and there is fire or a power cut or a flood in that building. So your entire website goes down. All your uh, just a minute. Yeah, it is fine. Okay. So imagine you host your shopping application in just one data center, and the center got a fire or a power cut or a flood in that building. Your entire website goes down. All your customer lose access. You lose money and reputation. And now imagine instead you spread your application across three different zones within the Mumbai region. If one zone has a problem, the other two are completely unaffected, right? Because they have separate power and separate cooling system. Your website stay up. This is the entire idea behind the high availability and the fault tolerance in AWS. And it is a concept you will uh, see repeatedly throughout this entire course. Okay. So if one availability zone in Mumbai goes down completely, does the Mumbai whole region goes down? It is like that. Anyone? You can answer in the chat. So the question is, if one zone in Mumbai goes down completely, does the whole Mumbai region go down? Yes, no, maybe. Yeah, correct. So that's why we have the other zones, and your data are in the data centers are the duplicated. Yeah, correct. Yeah, correct. That's it. Now we have the edge location that we are going to cover. So we are covering region and the zones, the core infrastructures. Now let's talk about the layer that sits closest to the actual end user, the edge location. Okay. So here is the problem: edge location solves. Suppose you have a main application and all your data sits in Mumbai region, right? A user in Chennai will get it responsibly fast, right? Will get access your resources faster because it is stored in the Mumbai. But what about a user in New York or London? Even every request has to travel all the way to the Mumbai and back. That's slow, right? So this is the exact problem the AWS edge location solves. So it small facilities location in many more cities around the world than there are full regions. So the AWS currently had hundreds of these in far more cities than in it has regions. So an edge location doesn't run your whole application. Instead, it cache it. Okay. Store a temporary copy of your frequently used request, image or video or a static web page close to the end user. This is the foundation of the Amazon CloudFront. So we have a service in the Amazon called CloudFront. The technology is the CDN. So CDN means caching your existing request like a static data, images, videos. So when you think of a Netflix, you are watching a movie on a Netflix. What you think the video is getting streamed in the Netflix from the servers? It is not like that. The CDN loads the data and it cache it. So the servers need not to handle the whole request. Okay. So you just need to understand like a edge location or small AWS facility, like which I told you, there is one service, Amazon CloudFront. So as the name says, there is a front of the cloud, something like a shield that any request will came in first. The Amazon CloudFront will take care of the request. Then if they don't have anything stored in the caching, they will redirect that request to the server. Okay. Then we have a shared responsibility model. This is one of the most important topic in the entire software solution architect certification. When you move to AWS, does AWS take care of everything you for you? A lot of us assume it's the cloud. AWS will handle all my securities. That assumption is wrong, right? And it has actually caused real data breach in the industry. They are not going to store everything or the permissions that we are creating, and for the encryption, they are just giving you the software. They are not managing your security part. You just need to handle by yourself. You need to configure it by yourself. So the AWS operates on something called share responsibility model, meaning security and compliance is a shared job between AWS and you, the customer. Okay, this is not like AWS guarantee everything. So AWS is mainly responsible for security of the cloud. This means AWS take care of the actual physical infrastructure, the data center, building, the physical security guards and cameras, the hardware, the physical servers, the networking equipment, the power and the cooling, and the core software that runs the cloud service, the virtualization layer. And you, the customer, will never see this layer, and you don't need to. Okay, and you are responsible for security in the cloud. This means you are responsible for what you put inside AWS, your data, how you configure it, your server, your operating system, patches, right, your firewall, security groups, who has access via the IAM role, and what is these IAM roles and security groups, firewalls, will learn in the later classes. And the encryption, you are storing your data in the plain text, so you need to handle this everything. Not AWS will be responsible. AWS will be responsible for providing the data center and the services. In that service, what you are doing, it's your responsibility. So think of renting a flat in a gated society. The society is responsible for the building's foundation, the security guard at the gate, the lift, the common area. Okay, that's security of the building. But whether you lock your own flat's door, who you give your house key, and what you keep inside your locker, that's entirely your responsibility. The builder cannot be blamed if you leave your own door open. Okay, so I would say this is all about today. That we have covered all the basics of the fundamentals. We have uh, something left to that we'll cover in the next session. And for this class, I just want to take away, like, uh, we have learned about a EC2 instance that is given by the AWS, which you manage more the guest OS, patching, firewall configuration, right? And we seen here we have S3 as well, where AWS manages almost everything about the infrastructure. But more real world data leaks and S3 happens because the customer misconfigured their bucket to the public. That is a security in the cloud failure, not the AWS. Okay, then we have the RDS database. It is a relational database which is managed by the RDS. You don't need to worry about the backups and the scaling, the server size. Everything will be managed by the AWS. So AWS manage the underlying OS and the database engine patching, but you still manage your own data, your access, permissions, and your network settings. You have given your account permission to some people, and they have deleted or modified your data. This is your own responsibility, not the AWS. Okay. I would say this is all about today's class, where we have learned the basic of the cloud computing, what is on premises and the cloud, why we need it, what was the reason, how the AWS works, what is cloud providers, and we have, as I said, we have a multiple cloud providers like AWS, Google. They have a GCP, and for the Microsoft they have a Azure. Okay, so these are the top known players in the system. Uh, we can use their services to manage our business. Okay. So I think this is all from today. So do you have Sachin in the call? So any
Uh,
of you student have any question? You can just ask me if do you have anything.
yes, guys, you can ask your final doubts, and today we can sum up, and tomorrow we can continue as a day one class. Anyone having question for the today's topic or any regarding your career doubts or anything, you can ask, please.
You can ask anything.
So which certification you would target after this course, basically? Is
Uh,
it a
mhm.
AWS architect or like which one?
The if you talk about the purpose of the certification, so we'll cover the AWS Solution Architect and the AWS Security. Okay, and we will focus on the certification with the in-depth knowledge and the practical knowledge which you will going to actually use in your job, right? Which will help you out in your exam as well as on your day-to-day life, how you are initiating an instance, how you are managing it, how you are connecting through a secure network. Okay, how you are storing your keys, private keys, so none of other can access it. How you can rotating your uh, secrets on the basis what the standard practice you should follow in the industry while you are working. Okay, so this course will give you the knowledge of the certification as well as what the DevOps guy or the cloud engineers actually do in the job in their day-to-day life.
So
Okay.
DevOps is also covered in this, right?
Yes, DevOps related to the AWS and the concepts which we need to understand, like we can say load balancer, right? We can will be defining our old load balancer, then the Nginx and Linux part will be also get covered because will be using the command line for doing everything. So this will be the part of the setuping the infrastructure. Okay.
So like any project we will be
Mhm.
working, like any assignment or
So
like that.
we'll be seeing everything in the practical by
Uh-huh.
creating a security group, groups, user groups, launching an instance and deploying it. So we'll be having projects as well. So as I said in the starting of the lecture, we'll be hosting our own application. Any of the application we can host. Suppose we can host a Java-based Spring Boot application on a EC2. Okay, and we can end-to-end configure it using the reverse proxy, which is Nginx. Okay, and
Yeah.
we'll be seeing how the S3 works, how the RDS works, how you can configure it, why we use it, why it was needed. Okay.
Okay. And can you please share the syllabus as well? I mean, so that we can just go
What?
through it once. Yeah.
Sorry, what?
Definitely, guys. We will share the syllabus content on your WhatsApp.
Okay.
Don't worry.
Thank you. Thanks.
Yeah. Anyone else has any doubts and questions? Want to clarify? Please ask. You can drop in the chat box as well if you want.
So I think today's session is good enough, sir. It was very informative.
Mhm.
So I hope all have enjoyed the learning, basic learning and understanding of the AWS cloud combo. And let's finish the session today, and we'll continue by tomorrow same time 11 a.m. as a day one class, right, sir?
Correct.
Yeah. So okay, guys. Thank you for joining the session today. Thank you, Uday, sir, for giving
Hmm.
the
Thank
knowledge
you.
in this basic
Thank you,
way.
everyone. Thank you, Sachin. Have a great day,
Thank
guys.
you.
Thanks.
Yes, yes. Thank you.